Monsignor Georges Lemaitre was a Catholic priest and notable cosmologist. He was a colleague of Albert Einstein and is notable for having put forth his Big Bang cosmological model in 1927. Lemaitre sought to answer a question in cosmology. Why is the recessional velocity of further galaxies greater than nearer ones? The idea was radical, and Einstein, even though he was impressed with Lemaitre's mathematics, rejected the idea initially. Lemaitre proposed that galaxies were not moving around in fixed Euclidean space. The space between the galaxies was stretching and growing. We could analogize this by a balloon being inflated. If we picture a balloon with many dots on it, the more the balloon expands, the more space there is between the dots. Lemaitre knew that Einstein's general theory of relativity allowed for this kind of expansion. However, this conclusion that Lemaitre drew was so radical that Einstein and others found it difficult to accept. There was also the implication that the universe had a beginning and hence a moment of creation. This was a true departure from previous scientific assumptions. The reason for this implication of a beginning is that we can continue to project the expansion into the past. If we continue to project this expansion into the past, we find that the universe grows smaller and smaller. There is a finite distance between galaxies, so we know that the universe could not have been expanding forever. We have very good evidence today that this initial expansion occurred some 13.8 billion years ago, plus or minus 100 million years. Nothing like this has ever been considered before in the natural sciences before the work of Father Lemaitre. Aristotle and St. Thomas Aquinas argued that evidence from reason could not establish a beginning to time and that natural philosophy would have to assume the eternity of the universe. St. Thomas Aquinas felt that the finitude of time in the past could only be known through the divine revelation of God. This would require faith. Isaac Newton made the same assumption. Lemaitre did not prove that the Big Bang was the beginning of the universe. However, his theory changed the landscape of the natural sciences as we know them. Lemaitre's theory will be confirmed 2 years later by Edwin Hubble. Hubble's survey of the heavens at the Mount Wilson Observatory showed that through a technique known as redshifting, that more distant galaxies are actually moving away from us faster than nearer ones. Hubble showed his results to Einstein, causing Einstein to change his mind. In fact, in 1933, Einstein said that this was the most beautiful and satisfactory explanation to creation to which I have ever listened. Lemaitre's theory has been confirmed in a variety of different ways since that time. It is one of the most comprehensive and rigorously established theories in contemporary cosmology. There was another remarkable discovery in 1965 by Arno Penzias and Robert Wilson. This discovery was made through a different approach. What they discovered was a kind of radiation distributed throughout the universe. It would be 2.7 degree Kelvin, and it would be the product of a very early cosmic-wide event. They received the Nobel Prize for this discovery in 1978. The Big Bang was also confirmed by data from the Cosmic Background Explorer COBE numbers 1 and 2, the Wilkinson Microwave Isotropy Probe, and more recently by the Planck satellite. So it would seem that 13.8 billion years ago, our universe took a quantum cosmological form where all four forces, gravity, electromagnetism, and the strong and weak nuclear forces, were completely unified. There was then an explosion causing the space-time manifold to come into existence, and energy emerged in it. There was a brief, rapid, cool, inflationary expansion period. During this time, the universe gained initial momentum, breaking through the gravitational parameters of its high density. The strong nuclear force breaks away from the electro-weak interaction, which then separates into the electromagnetic and weak forces.